Alright, question 8. The function f is such that 0 less than fx less than 1 for 0 less than or equal to x less than or equal to 1. Okay, so the function fx is trapped between that, 1 by 1 square on the 2D plane, if you think about it. Yeah? The trapezium rule with n equal intervals is used to estimate from 0 to 1 fx dx and produces an underestimate. Using the same number of equal intervals, for which one of the following does the trapezium rule produce an overestimate? Okay, so remember the condition. What's the condition for underestimate and overestimate? Well, so if the thing is convex, so convex looks like this, then it is an overestimate. How come? I mean, visually, it's clear visually, right? So if your axes are here, if you take the trapezia, like here, 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 say, the red straight lines are always above the blue curve. Always, always. Yeah? But if it's concave, let's say it's like this is concave, which is an underestimate. Why? Because, again, just drawing the picture. Again, the red straight lines are below the blue. Yeah? It's below the blue. That's why it's an underestimate. Good. Okay, so off we go. Let's check all of these then. So fx plus 1. Okay, so what transformation is this? You're moving the graph up by 1, right? Moving the graph up by 1. Does it change the convexity of the graph? I don't think so. Yeah? So I think A has nothing to do with it. How about B? If I stretch it in the y direction by 2, again, it doesn't change whether it's convex or concave. Yeah, convex stays convex and concave stays concave. Okay, how about C? So f of x plus 1, you're moving the graph to the left by 1, right? Again, it doesn't change the shape of the graph even, right? So therefore, convex still convex, concave still concave. Okay, how about D? From minus 1 to 0, f of minus x dx. This is basically the same as this guy, right? Because if you do a substitution, let's say u is minus x, what happens? Then this is 0, 1, f of u minus du, right? So the negative sign, you use it to swap the boundaries, then you get from 0 to 1, fu du, yeah? Which is the same as fx dx, right? Because of course the x and u are just dummy variables. Yeah? So the d is the same as the original, so of course it's not good. Yeah, it's of course also an overestimate. Oh, sorry, also an underestimate. Yeah. So that leaves us with E. Why is E correct? So this is negative fx, right? So if fx looks like convex, negative fx looks like this, right? Or something like this. Yeah. So when you negate a convex function, I mean my drawing is probably a bit sketchy, but you get the idea. So a convex function, when you negate it, it becomes a concave function. Yeah? A concave function, when you negate it, it becomes a convex function. Yeah? A convex function. Good. And I don't think it's too hard to see, right? Because convex means what? Convex means that you differentiate 2 times, it's greater than 0. Yeah? Let me scroll up a bit so I have space to draw. Why is it not behaving? So because convex is f double prime greater than 0, right? And concave is when f double prime is less than 0. So if you negate the function, then of course the sign changes. If you negate the function, the sign changes. So that's why convex becomes concave and concave becomes convex. So that's the reason why. So E is the answer.